Hello friends, I welcome you in lecture number 15 on graph theory. In this lecture also we will discuss about reachability in a graph. In previous lecture we have discussed that if we have some vertex v in the vertex set of a given graph, then this vertex v is said to be reachable from another vertex denoted by small u if there exists a path from vertex u to vertex v. If there exists a path from one vertex u to another vertex v, then we say that vertex v is reachable from another vertex u. Now here we are going to define reachable set of a vertex. What is the meaning of reachable set of node or vertex small v in the vertex set of a given graph? So reachable set of vertex v is the set of all those vertices from the vertex set which are reachable from this vertex small v. The set of nodes which are reachable from given node v, that set is called reachable set of vertex v, and we will use this notation R of v for the reachable set of vertex v. We understand with the help of example. Here I have written that definition. Let G equal to v comma e be a directed graph, and let small v be a vertex in the vertex set v. Then the set of nodes which are reachable from given node v is said to be the reachable set of v, and reachable set of v is denoted by R of v. So we understand with the help of this diagram. Here we have taken a diagram with 10 vertices or nodes. Now suppose we are interested in the reachable set of node v1, then we have to collect all those nodes from the given graph which are reachable from v1. That is, we have to decide all those nodes in this graph for which there exists a path from v1 to that node. Suppose we start with v2, then we can see that there exists a path from v1 to v2. That path is this is. If we consider this path, say p1, then p1 is a path from v1 to v2. Therefore v2 is reachable from v1. Therefore we will consider v2 in this set, and for the sake of completeness we will assume that every node is reachable from itself. So we will include v1 also. Okay, remember we are assuming that every node is reachable from itself. So whenever we are writing the reachable set of any node, it will contain at least one node, that node itself. So I am writing v1, then v2 is reachable from v1. Now I check for v3. So here we can see that there exists a path from v1 to v3 also. Therefore v3 is also reachable from v1. What about v4? So if we extend this graph, then there exists a path from v1 to v4 also. Therefore v4 is reachable from v1. Similarly, we can observe that there exists a path from v1 to v5 also. Therefore we will include v5 in this set. v5 is also reachable from v1. Same thing for v6. You can see there exists a path from v1 to v6 also. So v6 is also there. What about v7? So there is no path from v1 to v7 because this is pointing in this direction. If this arrow was in this direction, then v7 was reachable from v1. So there is no path from v1 to v7. Therefore v7 is not reachable from v1. Similarly v8 is also not reachable from v1. These two are isolated, so they are not reachable from any node. This is the reachable set of vertex v1. Similarly, we can write reachable set of vertex v2. We start with v1 and we can observe this graph. If we go from v2 in this direction, then we are able to find a path from v2 to v1. That means v1 is reachable from v2, so we have to include v1 in this set. We are including v2 because every node is reachable from itself, that is our assumption. And for v3 we have this path from v2, so we include v3 also. v4 is also reachable along this path from v2. v5 is reachable from v2, so we include v5 also. And for v6 also we have a path, and v7 is not reachable from v2. v8, v9, v10 all are not reachable from v2. This is the reachable set of v2. Now we write reachable set for vertex v3. We start with v1. We check whether v1 is reachable from v3 or not. So if we go in this path from v3 to v4 and from v4 to v1, so v1 is reachable from v3. For v2 also we have to go along this path. If we go from v3 to v4, then v4 to v1, and then from v1 to v2, then we have a path from v3 to v2. Therefore v2 is also reachable from v3, and v3 itself is reachable from v3. What about v4? So for v4 we have this simple path. For v5 we cannot go in this direction, there is no edge from v3 to v5, but if we observe, if we go along this path, then we are able to find a path from v3 to v5. That means v5 is also reachable from v3, and if we extend this path starting with v3 and in this way, then v6 is also reachable from v3. Now v7 is not reachable from v3. Similarly v8, v9, v10 are not reachable from v3. Now we find reachable set for v4. R of v4. We start with v1, so there is obviously a path from v4 to v1, so we will include v1 as well as v2 and v3 also. You can see this is a path from v4 to v1. Then if we consider these two edges, it is a path from v4 to v2. If we include these three edges, then we obtain a path from v4 to v3. Then v4 is reachable from itself. For v5 we have to consider this path, that is v5 is also reachable from v4, and similarly v6 is also reachable from v4, and remaining vertices are obviously not reachable from v4. Now we write for reachable set of vertex v5. Now for v5 we first check whether there is a path from this v5 to v1. Then we obtain this path v5 to v3, then v3 to v4 and v4 to v1. That means v1 is reachable from v5. Similarly, if we extend this path, then we obtain a path from v5 to v2. So we include v2, and if we go in this direction, first we go from v5 to v3, then v3 to v4, v4 to v1, v1 to v2, and then v2 to v3. Then we have a path from v5 to v3 also, and for v5 to v4 we have these two edges in the path. v4 is also reachable from v5, v5 is reachable from itself, v6 is also reachable from v5, and no other vertices are reachable from v5. Now we check for V6. For V6 we can see there is no edge coming out of V6. There are two edges which are going into V6, but there is no edge coming out of V6. That means no node is reachable from V6 except V6 itself. Therefore, reachable set of V6 is having only one node, V6 itself. Similarly, we check for V7. For V7, we can see there is an edge from V7 to V6. That means V6 is reachable from V7, but no other vertex is reachable from V7. So this set has two vertices, V6 and V7. What about reachable set of V8? So we can see there is an edge from V8 to V7 and from V7 to V6. That is, there exists a path from V8 to V6, therefore V6 is reachable from V8. Similarly, V7 is also reachable from V8 and V8 itself. So this is the reachable set of V8. And vertices V9 and V10 are isolated, so their reachable set consists of only one vertex, that is V9 and V10. So in this way we can identify the reachable set of a given vertex. We have to identify all those vertices or nodes which are reachable from a given vertex. Now, as we discussed for reachable set of a vertex, we can define reachable set of a subset of a vertex set also. Suppose S is any subset of a vertex set V of a given graph, then reachable set of this subset S is the set of all those nodes of V which are reachable from any node of S. The set of nodes which are reachable from any node of this set S is called the reachable set of capital S. So that is another definition for any subset S of a vertex set V. The set of nodes which are reachable from any node of S is said to be the reachable set of S, and reachable set of S is denoted by R of S. So we can talk about reachable set of a subset of vertex set also. For example, if we consider S equal to say V6 and V7, then reachable set of capital S is the set of all those nodes which are reachable either from V6 or V7 or from both. So first we consider that which vertices are reachable from V6. So we have obtained that there is only one vertex V6 which is reachable from V6 itself. Then for V7 we have seen that V7 and V6 are reachable from this V7 is reachable from V7 and as well as V6, and there is no other node which is reachable from V6 and V7. So reachable set of this subset is that subset itself. But suppose I consider another subset, say capital X. Instead of S, I am using capital X, equal to say V2, then V7, V2, V7, V8 and V10. And we write the reachable set of capital X. So we have to write all those vertices which are reachable from any node of this subset capital X. So first we check for V2. So we have obtained, for V2 we have obtained all these vertices, they are reachable from V2. So that I am writing here all these vertices V1, V2, V3, V4, V5 and V6. All these vertices are reachable from V2 because they are in the reachable set of V2. Now what are remaining? So V7 is remaining. So we know that V7 is reachable from itself. Similarly V8 is also reachable from itself. And V9, what about V9? So V9 is not there. Here V9 is not there and it is isolated point. So it is not reachable from any node of this subset capital X. And we will include V10 because it is reachable from itself. This is the reachable set of capital X. Suppose we are writing V9 here, then this is going to be vertex set capital V. So in this way we can decide reachable set of a vertex or reachable set of a subset of a vertex set. Now here we can observe that reachable set of X is capital V. So this type of sets whose reachable set is the vertex set of a given graph are given special name if they satisfy some additional property. So that name is node base. What is the definition of node base? So suppose we have a directed graph G and capital X is a subset of vertex set V. Then capital X is called a node base if reachable set of capital X is V and no proper subset of X has this property. That is, there does not exist any Y which is a subset of X, it is different from X, and R of Y equal to V. There does not exist any proper subset of X such that reachable set of that proper subset is equal to V. So here we can check whether this capital X is a node base or not. We have taken V2, V7, V8, V9 and V10, that is V2. We have taken these vertices V2, V7, V8, V9 and V10. So now if I want to prove that this capital X is a node base, then I have to check whether there is no proper subset of X for which this property is satisfied. Let me write X here. Capital X is V2, then V7, V8, V9 and V10. V2, V7, V8, V9 and V10. So we are considering V2, then V7, V8, V9 and V10. So we have to check whether any proper subset of X exists such that reachable set of that proper subset is also vertex set V. So suppose I consider capital Y equal to, here we observe that we have taken V7 and V8 and V7 is reachable from V8. So suppose I exclude this V7, then I will have V2, V8, V9, V10, and this is not equal to X and it is a subset of X, that is Y is a proper subset of X. Now we write the reachable set of this subset capital Y. So we start with V2. We have to write all those vertices which are reachable from V2, that we can directly write from this vertices V1 to V6 are reachable from V2. So I am writing them here: V1, V2, v3, v4, v5 and v6. Now I have to check for v7 whether v7 is reachable from any vertex of this set. So here we have v8 and it is obvious that v7 is reachable from v8. So I will write v7 also. Reachable set of capital Y means all those vertices which are reachable from any vertex of given set Y. So here v7 is reachable from v8, so we are including v8 here. Then v8, v9, v10 are reachable from themselves, so we are mentioning them here. So now we find that reachable set of Y is also capital V. That means this capital X is not a node base. Capital X is not a node base because Y is a proper subset of X with the property that reachable set of Y is capital V. Now, if there does not exist any proper subset of Y, say Z, there does not exist a proper subset of Y, say Z, such that R of Z equal to vertex set V, then Y is called a node base. So you can verify that there is no proper subset of Y such that R of Y equal to V. Therefore, our set Y, this set Y having these vertices V2, V8, V9 and V10 is a node base. Capital Y is a node base because reachable set of Y is the vertex set V and there is no proper subset of Y such that this property R of Z equal to V is satisfied. So this is very interesting concept. Suppose you are interested in the node base, then what you can do is you can start with single vertex, then you can start with two vertices. In that way you can add vertices and you can check the reachable set of those sets generated by adding those vertices. And once you obtain that reachable set is V, then you stop and write down that subset. Here we can observe that if we consider instead of this V2, V8, V9, V10, if we consider another set which is V5, V8, V9, V10, then this is also a node base. R of Y will be equal to V. So you can have more than one node base. You can check whether reachable set of this set is V or not. So there can be more than one node base also, but the number of nodes in any node base are same. You can check that there are 4 vertices in any node base, and there are certain properties of node base which will help us to decide the node base. For example, you can see here in this node base I have taken isolated vertices. V9 and V10 are isolated vertices and that I have included in both the node base. So remember, whenever you are writing a node base, then isolated vertex must be present in your node base. And another property is here we have included V8. So we can see that in degree of V8 is 0. There is no edge whose terminal vertex is V8, or there is no edge going inside V8. That is, in degree of V8 is always 0. So every vertex whose in degree is 0 must be present in the node base. So we have included V8 here, and every vertex if we have elementary cycle in the given graph, we can see that we have elementary cycle here from V1 to V2, V2 to V3, V3 to V4 and V4 to V1. So here all the vertices are different. So this is an elementary cycle. So you can consider one vertex from elementary cycle. So you can consider either V1, V2, V3 and V4. We have taken V2 here. Here we have taken V2. So one vertex from elementary cycle can be considered in the node base. So if you remember all these properties, it will be helpful to write down the node base. I am again reading all these properties which will be helpful in writing the node base. What we will take care is every isolated point of a diagraph must be present in a node base. Any node whose in degree is 0 must be present in node base. This is important. If we are writing vertices in the node base, then no vertex in the node base is reachable from another node in the node base. Here all these vertices, if we consider these 4 vertices, then no vertex is reachable from another vertex. In capital X, we had taken this V7 was extra vertex in capital X that we have removed here because V7 was reachable from V8, so that is not allowed in node base. Any two vertices in the node base are not reachable from one another. So this is also important, that no node in the node base is reachable from another node in the node base. From the nodes lying on an elementary cycle, any one node could be chosen as an element of a node base. That is, if we have an elementary cycle, then from all these vertices we can choose any one node in the node base. And if our graph is a cyclic graph, that is graph having no cycles, then node base consists of only those nodes whose in degree is 0. In an acyclic graph, that is if a graph has no cycles, then in node base you have to write only those nodes whose in degree is 0. And for a simple diagraph, we may have more than one node base. However, every node base has the same number of nodes. So that is the idea of node base. A node base is a subset capital X of a vertex set V of a given graph G, such that reachable set of X is V and there does not exist a proper subset V of X such that reachable set of Y is capital V. Here I have taken one graph in which we can check about node base. So if we are interested in the node base for this graph, first we will check whether there is any isolated point or not. So here there is no isolated point, and here we have this V3 to V4 and V4 to V3. So we have one cycle here, so we can consider one element from this cycle, and we can check whether there is any vertex whose in degree is 0. So this V1 is the vertex whose in degree is 0, so that can be included. But the best way to write down the node base is first you find out the reachability of each vertex. For example, first we check for reachability of V1. Then we will start with V1. V1 is reachable from itself. V2 is also reachable from V1, so we write V2. V3 is also reachable from V1, so we write V3 here. And similarly, if there exists a path from V1 to V4, therefore V4 is also reachable. So what we obtain? We obtain all the vertices, that is vertex set of a given graph. We have V1, V2, V3 and V4 equal to V, and we find that reachable set of V1 is V. So this will work if we consider X equal to set containing only V1, then reachable set of X is V, and there is no proper subset of X. Here proper subset of X is only empty set. So reachable set of empty set is never equal to V. So here we obtain that reachable set of X is V. Therefore X is a node base. So whenever we are writing the node base, we have to first start with single vertex. If we obtain reachable set of single vertex equal to V, then the set containing single vertex becomes a node base. Now suppose R of X is not equal to V, then we will add one more vertex by considering all these remarks, and then we will check whether reachable set of that modified set is V or not. In that way we will continue. So in this way we can decide the node base for a given graph. You can try for this. So I stop here. Thanks for watching.